Now let us start question number 1. It will be like a revision because we corrected it yesterday, but I think we can start with this question. Question number 1, which statement about the isotopes of nitrogen is correct? Number of electrons, we have 3 columns, number of electrons, number of neutrons, and the mass number. And on suggestion A, we have same number of electrons, same number of neutrons, and same mass number. B, same number of electrons, same number of neutrons, and different mass numbers. C, same number of electrons, same different number of neutrons, and different mass numbers. And the last, different number of electrons, different number of neutrons, and different mass numbers. And here you have to choose the right answer. So I give you like 30 seconds, you think about it, and then you suggest the right answer. Okay, now you can use the chart to suggest the answers. Or as we did it yesterday, you can write here. If you write A, but make sure you write your name on this side or this side. Don't write in the questions. Like here, for example, you don't write here. So make sure if it is if, you can write if, and then you give your suggestion, like A, for example. It's an example. And if it is Pacific, you can write Pacific, and then you put there B, like this. And if that is not easy to you, you can use the chart. Okay, so let me check if we have suggestions. For question number 2, there is no suggestion. So we are still waiting for you to give your suggestions. What do you think is the right answer? Question number 2. Good. So for question number 2, we have Frank, who has suggested D, and Aline, who has suggested C. Now let me Aline. Yes, Frank. Frank?
Yes.
Can you why the right answer or the answer you have suggested is D? A short explanation.
Yeah, it's D. It's D because hydrogen gas, it contains 2 atoms of hydrogen, which means that it is diatomic.
Yes.
So one hydrogen contains 2, 1 proton and 1 electron. and another like that, so they become 4.
Yes.
Now, to then we multiply by the Avogadro's number to change it to moles,
Yeah.
which give us 2.4 times 10 power 24.
Good. So I think everyone understands why the right answer is D. So the right answer is D. And for Aline, who suggested 1.2 times 10 power 24, then he didn't consider hydrogen being diatomic. So we should always remember that some substances, some elements, they exist in nature as diatomic molecules. So we have to consider the particles in one atom and the particles in the other atom, giving us 4 particles in total. And when you multiply with this, you get the right answer, which is D. Thank you, Frank.
Welcome.
Good. Now, Aline. Aline,
Yes,
have you understood why it is D?
I have understood this.
Okay, good. Now let us ask Yves Dusabe. Yves, are you there?
Yes. Yeah.
So is everything clear?
Yeah, I get it.
Okay, good. So we can go to the next question. Good. So we have the third question. The third question, which is so question number 1. So we go to the third question. Which statement is correct for the ion 9,4 beryllium 2 plus? You know the meaning of this 2 plus? So let me give you time. You read the question and then you suggest the right option. Here we are considering the number of subatomic particles, the electron arrangement. You know this from O level. And we even covered this in some units like unit number 2. So you should be able to find the right answer. Okay. Suggestions, please. The ion contains 15 subatomic particles in the nucleus. B, the ion contains more protons than neutrons in the nucleus. And C, the ion has an electron arrangement of 2,2, and most of the total volume of the ion is empty space. So which one is right? In the 4 statements we have here, which one is right? We have one suggestion that is from Frank. And the suggestion is D. Aline also has suggested D. Frank and Aline have suggested D. And what about the others? Because we also have Ishimwe Alain Pacific. Pacific. Hello, Pacific. Stefan. We also have Stefan. Okay, now let's ask someone to tell us why the right answer or what they have suggested is D. Let us ask Aline if she can explain why it is D. Aline, can you help? Can you give us an explanation? Aline? Aline? Maybe she's not ready. Frank? Frank, can you give us an explanation? Why did you choose D?
Yes.
Yeah, your choice is D, but why is it D? Why can't it be A, for example? What is wrong with the first statement? A, statement A. Okay, so it seems like no one is ready to give us an explanation. So let us analyze why it cannot be A, or what is wrong with statement A, what is wrong with statement B. The iron contains 15 subatomic particles, but we know in the nucleus, but we know that the representation of a nuclide is always X, representing the chemical symbol of an element, and here we put A and here Z. And this A is the total number of particles in the nucleus. And what we have here is 9. So we do not have 15 subatomic particles in the nucleus. Why? Because the mass number here is 9. So we have 9 subatomic particles in the nucleus. So A is wrong. And it cannot be suggestion B. Why? The iron contains more protons than neutrons. It's very simple. We have the atomic number, this one, which you can see we have beryllium, 9, and 4. So if we can get the number of protons. When you take protons and you add neutrons, you get the atomic number. So 9 is equal to 4. The atomic number is equal to the number of protons plus number of neutrons here, then that will be 5. So we have more neutrons than protons. We have more neutrons than protons, so this statement is wrong because we don't have more protons than neutrons. And then the iron has an electron arrangement of this. This one also is not correct. Why? Because we have 4 electrons in the neutral atom, but this is an iron with a double charge, showing that it has lost 2 electrons. So if it has lost 2 electrons, then the electron arrangement is 2 only. So it is not 2 and 2. This is wrong. We have 2 only because because we have the iron has lost 2 electrons, it is remaining with 2 electrons. So the right answer is D. Most of the total volume of the iron is an empty space. We remember this from the atomic model of Ernest Rutherford from the gold foil experiment. So the right answer is D. Note it down, please, somewhere. And then we go to the next question. And the next, there is a question? Okay, let me check. Okay. So what's wrong? I'm not being able to unmute myself. I'm sorry that I'm not answering. Oh, so well, let me say that. Okay, listen, guys. To avoid some background noises, we have decided to allow you to unmute yourself only when you are about to tell us something. So if I call your name, you will find or you will see a message on your screen asking you to unmute yourself. That is when you can unmute yourself. Otherwise, you cannot. So that is for the reason of avoiding these background noises. So you will only be able to unmute yourself when I tell you to do so. When I ask you, you will see a message. Then you can unmute yourself and then you tell us what you think. And after when you're done, I will also block it again. So question number 4. Which ion will be deflected most in a mass spectrometer? You remember how a mass spectrometer works? We know that it works with positively charged particles. And here we have different particles. And if you remember, we've seen that the deflection depends on the mass and the charge. And that is the reason why we always combine mass and charge. So we consider that they are deflected according to mass to charge ratio. So you will consider the mass to charge ratios we have for the different particles that are suggested, and then you choose the one which will be deflected or most in a mass spectrometer. We have the particles we have, it is oxygen 16, 1 positive, oxygen 16, 2 positive, oxygen 18 positive, and oxygen 18, 2 positive. You will decide which one will be deflected most. You have 30 seconds to think about it, and then you give your suggestions. Okay. Okay. So we have a suggestion from Aline. Aline has suggested B. Aline has suggested B, and Frank has suggested C. So far we have 2 suggestions only. So we don't have more suggestions. So who wants to tell us why? The answer, we have a suggestion from Giselle, and that is D. Now let's go to the explanations. Giselle, can you tell us why it is D? Giselle? Giselle? Giselle is not responding. Now, maybe we can talk to Frank. Frank? Frank also is not responding. Aline, can you tell us why it is B?
Thank you. I think I say that on number 4, the answer is B, because if you calculate mass to charge ratio, you will find that on 16, oxygen 2 plus, it has the lowest mass to charge ratio, which is equal to 8. With lower mass to charge ratio, we will find that the ion will be easily deflected, hence being diffracted most. Thank you.
Okay, that is the right explanation. Thank you very much. Is it clear to everyone? Feel free to ask the questions or ask for more clarification if needed. You can use the chat. Or if you want to speak, you can raise your hand. If you raise your hand, I can see it, and then I give you the floor. So if it is clear to everyone, now I think you can raise your hand. Okay. We have Pacific. Pacific.
I don't understand why. Yeah, I don't understand why it is not C. Yeah.
Okay. So let us hear the question of Eve. Maybe you have the same question, and then we will give you the answer at the same time. Eve, what's wrong?
Yeah, I don't get it very well.
Sorry?
I don't get it very well.
Okay, good. Now, let us ask Aline to explain again. Aline, can you give more clarification?
Okay, thank you. Adding on the explanation I gave before, let's first calculate mass to charge ratio of every ion. On A, you are going to find that it's 16/1, which is going to give 16. Then on B, it's going to be 16/2 to be 8. C, it's going to be 18/1, which is going to give 18. Then on D, we'll find that mass to charge ratio is equal to 9, which is the result of 18 divided by 2. Then we know that if like you are to pull something, the one which has weaker energy is the one you are going to pull easily, meaning that Also, the magnetic field in the mass spectrometer is going to pull easily this ion on B, as it has low mass to charge ratio. After having low mass, if you are able to diffract something easily, it means that you are going to diffract it most. Thank you.
Yes. Okay. If we have Eve and Pacific, if you're not satisfied, you can raise your hand and we add more explanation. If you don't raise your hand, then I will consider you are satisfied. Eve?
Yes, I get it.
It's
Thank
okay
you.
now?
Yeah.
And Pacific?
Yeah, I understand now.
Okay, good. Now we can add something. I can add something. Think about if you have particles and there is a force which is pushing the particles. The particle which is heavier and the particle which is lighter, which one is going to be pushed easily? Because we have a magnetic field. The magnetic field is there to deflect particles. And if the magnetic field is applied, which particle will be pushed or deflected more easily? Is it the heavier one or the lighter one? So if you take the example of pushing or the wind which is blowing, and you have two materials, one which is lighter and the one which is heavier, you can see that the heavier one will resist from being blown away, but the lighter one will easily be blown. So it is the same, just like that in the mass spectrometer when we are in the magnetic field. The particle which has a greater mass to charge ratio will resist from that deflection, but the lighter one will immediately be deflected. So I think now it's clear. Okay? So let's go to the next. Now the next question is number 5. Consider the composition of the spaces W, X, Y, and Z below. Which species is an anion? Remember the characteristics of anions and characteristics of cations. So you will consider the number of particles we have here, the subatomic particles, and you choose from W, X, Y, or Z the particle which is an anion, which has a negative charge. So you have 30 seconds to think about the right answer. Eve,
B.
do you get why the right answer on number 6 is B?
Yeah, I know it.
You know it. Okay, so I hope it's clear for everyone.
Yes.
Okay, good. Frank? Frank? Is it clear why it is B?
Yeah,
Okay, good.
it's clear.
Good, good. And so let's go to the next question. Next question is question number 7. What is the difference between two neutral atoms represented by, there is a question. Yes, Pacific?
Number C, that question. Above that question. Not understand.
Which one?
Let me see. Number 6.
Number 6. Okay, let me explain. For number 6, we said that Pacific, Pacific,
Yes.
how we calculate the relative atomic mass.
Yeah, I tried to do myself, but the answer are not much.
So let us take 60%. Okay, we have 69 times 60, and we add 7 times 40 over 100. This, was it like this?
But me, I get like something 41,684.
69.4.
Me, I got 41,684.
Let me check.
What?
Oh, la, la. Pacific, are you there? Pacific,
Yeah.
can you tell me how you calculated your answer? How you proceeded to
What?
go to the answer you have? You can write it here. Write your answer here.
I didn't understand. What?
You can write the answer you have got on this side. The left
Yeah.
screen.
Let me use the chat.
Ah,
Can I use chat?
you want to use chat? So we have Okay, listen please. When we are calculating the relative atomic mass, we always take the mass of the isotope, let's say isotope 1, times its aboutness, the percentage, and you add the mass of the second isotope, isotope 2, times its percentage aboutness, let us call it 1 and this one 2, up to the last, and then you divide with 100 because we are using percentages. So I'm not sure if you did it like this.
I got it was the calculator.
It was a problem of your calculator?
Yeah.
Okay, good. Thank you.
Mm.
Now we go to question number 7. Question number 7, we have, what is the difference between two neutral atoms represented by the symbol 5927CO and 5928Ni, nickel and cobalt? So what is the right answer? You have some seconds to think about it, and then you give your suggestions. Number 7, we have D from Aline, and we have D from Giselle. We also have C and C from Eve and Alain. So what is the right answer? I want someone who has suggested D to give us an explanation. The one who wants to give us an explanation why they have chosen D, you can raise your hand. Raise your hand if you want to tell us why you chose D. Or you can even use the chat if you want to, your microphone to be unmuted so that you can explain. Between Aline and Giselle, Giselle, okay, let's ask Aline. Aline, do you hear me?
Thank you.
Yes.
On number 7, I choose D because because if we try to calculate number of neutrons, we'll find that on cobalt we have 31 neutrons, while on nickel we have
Yes.
on 31. By this, we find that number of neutrons and number of neutrons are not the same. So even on protons, we know that protons is equal to atomic number, and we see that here there is different atomic numbers. The same case on electrons, which means that those two neutral atoms have different number of protons, neutrons, and electrons. Thank you.
Very good. So if you want, you can simply calculate the particles. For cobalt, we have 27 protons, we have 27 electrons, and we have 32 neutrons. And for nickel, we have 28 protons. The number of protons is always equal to the number of electrons. And we also have 31 neutrons. So be it the number of protons, electrons, or neutrons, everything here we have here, the set of these values, the three values, is totally different from the one we have for nickel. So number of protons, neutrons, and electrons are all different for the two particles. Any question? If you have a question, please raise your hand. If you have a question, you can raise your hand. Stefan, are you there? Stefan? Stefan Nwari. Okay. So if we have no questions, we can go to the next question. So the right answer here, you can note it down, it's D. The right answer is D, this one. So we clear everything from the screen, and then we go to the next question, which is, how many neutrons are there in the ion? How many neutrons are there in the ion oxygen 18, 2 negative? Oxygen 18, 2 negative. You have 30 seconds, and here you will need to use your periodic tables. And if you don't have your periodic tables, let me remind you the atomic number of oxygen, that is 8. That is the atomic number of oxygen. The atomic number of how many neutrons are there in the ion? Here we have suggestions. Aline has suggested B. We also have Pacific, who suggested D. And we have Giselle, who suggested A. And Eve has suggested A. Frank has suggested A. So now we can calculate. A says we have 8 neutrons. 8 neutrons. No. So Eve says it was a mistake. The answer is B. Now let us ask Eve. Eve, can you tell us why it is B?
Yes.
Yeah. You're welcome.
It's a B because you take atomic mass minus protons in order to get neutrons.
Yeah.
And that you take 18 minus 8 to get 10.
18, that is the atomic the mass number minus the atomic number, which is 8, and we get 10. So the fact that we have a charge here, it doesn't affect the particles in the nucleus. What can is the number of electrons, and electrons are not in the nucleus. So we know that neutrons are in the nucleus. They do not change whether an atom gains electrons or loses electrons. So the right answer is B.
That ion to affect the electrons.
Yes. The charge on a given particle affects the number of electrons and not the number of nucleons. You know, the particles in the nucleus, we can also call them nucleons.
Yeah.
Good. So we go to the next question if we don't have questions. If you have a question, you can raise your hand and then we give you the microphone. I guess there is no question, so everything is clear. And we go to question number 9 and number 10. So today we will finish the first part of our exercise, and then you will keep on trying the questions of section number B that will be discussed next time in the next session. So let's go to question number 9. What is the symbol for a species that contains 15 protons, 16 neutrons, and 18 electrons? 15 protons, 16 neutrons, and 18 electrons. Suggestions? We have a suggestion from Aline, and she has suggested D. We have a suggestion from Eve, who has also suggested D. And we have a suggestion from Frank. The suggestion is D. And now let us D. We have 15 protons, so this is 15, and we have that here the mass number is 31. If we take 15 number of protons plus the number of neutrons, we get 31, so this is right. And you can see here we have 18 electrons while the protons are 15, so we have 3 extra electrons giving us a charge of -3. So that is to say that D is right. So you are right. D is right. That is the right answer. Right, right, right. If there is any question, you raise your hand and we give you the floor so that you can ask your question. And if everything is clear, we can go to the next question. For number 9, the right answer is D. Question number 10. What is the correct sequence for the processes occurring in a mass spectrometer? We remember the different parts or the steps involved in the process of how a mass spectrometer works. And the question is asking to choose the right sequence of the processes taking place in the mass spectrometer. You have 30 seconds to think about it, and then you give us the suggestion. We have a suggestion from Aline. Oh, even Stefan is there now. We have Stefan, we have Eve. So here there is A. It's A for Stefan and even A for Eve. And we also have Alain Pacific with the suggestion which is A, and Frank, the suggestion is also A, and allow me to ask Stefan to tell us why the answer is A. Stefan, can you hear me? Stefan? Stefan is not responding. Let's ask Pacific. Pacific, can you tell us why it's A?
It is A because the sample starts from it begin from the vaporization.
Yes.
It becomes the so, and it introduced as the vapor into the ionization chamber.
Yeah.
So in the ionization chamber, the vaporization the heat, like the heated electrically heated mitochondria gives the off, which are attracted to the electron trap, which is positively charged plate. So also that sample is being ionized to acceleration chamber,
It is
and
ionized.
in the
So we know that
yeah,
it is ionized. Okay.
and in acceleration chamber, the positive ion, so that they move rapidly through the machine at the high and constant velocity.
Yeah, yeah.
And yeah, that's it.
Yeah, and then it goes to the deflector, the magnetic field.
Yeah.
So the right answer is A. The sample is first vaporized,
Yes.
it's ionized, and the positive particles are attracted by a negative potential, which accelerates them to give them the same velocity. And then they go to the magnetic field where they are deflected according to the mass to charge ratio. Okay, so this is the last question. And you can note down the right answer. That is A. And then we keep this, the remaining part, section B, for the next session. I hope you will get enough time to work on them. And if possible, you will be writing the answers in the, you can even share with us your screen so that we can see what are the answers that you have suggested. But we will also have a discussion so that we can all have a common understanding on what the right answers are. So let me thank you very much, guys, for being there, for having joined the class of today, and for your active participation. I think even those who have not been very active, it is not because they didn't want to be active, but maybe because of the internet problem. And I'm very sure that, or I hope that next time it will be resolved. So keep in touch and keep it up, please. It's very good from you to be always committed and always ready to learn. See you guys. Thank you very much.
Oh, genius!